Hello dear student friends. Dr. Bapuji Salunkhe Institute of Engineering and Technology Kolhapur welcomes you all to e-learning platform. This is Science and Humanities Department. Myself Mr. Sudarshan Dinkar Mahadik, and the course which we are learning is Basic Science Physics. The unit which we are learning is Electricity, Magnetism and Semiconductors. The learning outcome for our today's lecture is Explain the specific resistance. Specific resistance or a resistivity. Simply resistivity, which is denoted by letter rho. This is a letter rho. Resistance, specific resistance or resistivity are the similar things. Okay. Now consider this diagram. This is a diagram of some conductor. This is a conductor. The length of that conductor is a capital L. I is the value of a current which is flowing through that conductor, and this capital A is area of cross section of this conductor. Okay, area of cross section, which evaluates as a pi r square, where r is a radius of this conductor. Okay, so A is a cross sectional area, L is the length of the conductor, and A is a cross sectional area, I is a current flowing through the conductor. Now suppose if we increase the cross sectional area of this conductor, this is our case. If we increase the cross sectional area of this conductor, means if we increase technically the radius of this conductor, means again if we increase this cross sectional area of the conductor, see this is a cross sectional area of the conductor. If we increase its radius, means if we increase its thickness, then also the area of cross section gets increased. So this is the case we are speaking about. We have increased the radius of the conductor here. Okay, we have increased the radius of a conductor here. That is, in a rough words, we have increased its thickness. The length is the same. Length is same. We have just increased the area. So what happens with the resistance then? It is observed that if the thickness, that is cross sectional area of a conductor, is increased, the current flowing through it also gets increased. That is, resistance R of a conductor gets increased. Okay? Sorry, resistance R of a conductor gets decreased. Means if we increase the cross sectional area of this conductor, then value of a current increases, means the value of R gets decreased. Value of R gets decreased. This is the case. Okay, means if we increase the cross sectional area, then resistance of a conductor gets decreased. This is what we observed. जर का आपण या कंडक्टरचा क्रॉस सेक्शनल एरिया वाढविला तर त्याचा रेजिस्टन्स आहे तो कमी होत जातो. मीन्स मॅथमॅटिकली वी कॅन राईट रेजिस्टन्स आर इज इनव्हर्सली proportional to cross sectional area. If we goes on increasing the cross sectional area, resistance will be decreased. If we decrease the cross sectional area, then resistance will be increased. So this is a mathematical relationship between resistance and cross sectional area. If we increase, we have increased here the cross sectional area, so resistance gets decreased. So we can call it as equation number 1. So this is the one type of a situation. Let us see another situation. Suppose we increase the length of this conductor and keep cross-sectional area as it is. We increase the length of the conductor and keep cross-sectional area as it is. Means this situation. We have increased the length of the conductor and have kept the cross-sectional area constant. In this situation, what does happen with the resistance? रेजिस्टन्सच्या संदर्भात काय घडते जर आपण कंडक्टरची लेंथ वाढवली आणि क्रॉस सेक्शन एरिया आहे तसाच ठेवला. बघूया काय घडते. It is observed that if the length of a conductor L is increased, the resistance R of a conductor is also gets increased. जर आपण कंडक्टरची लेंथ वाढवत गेलो तर रेजिस्टन्सची व्हॅल्यू सुद्धा काय होत जाते, वाढत जाते. ओके, this is the case. If we increase the length, resistance also goes on increasing. Okay, means there is a direct relationship between resistance and the length of a conductor. If we increase the length of a conductor, resistance also goes on increasing. So we can call it as equation number 2. If we combine the situation from equation 1 and equation 2, we can simply write resistance is directly proportional to L and inversely proportional to cross sectional area A. Means R is proportional to L upon A. L upon A. To remove this proportionality sign and bring here equal to sign, we have to multiply this side by some proportionality constant. Okay, so in this way R is equal to rho into L upon A. This is a proportionality constant rho, and this proportionality constant rho is nothing but a specific resistance or a resistivity of a conductor. Specific resistance or resistivity of a conductor. Okay, so this is specific resistance. R is equal to rho L upon A. Okay, resistance of a conductor, specific resistance, length and cross sectional area. Rho is equal to RA upon L is a simply formula for a specific resistance from this formula. Okay, simple mathematical arrangements. Specific resistance or resistivity is a characteristic of a material. पहा, स्पेसिफिक रेजिस्टन्स किंवा रेजिस्टिव्हिटी ही एखाद्या मटेरियलची कॅरेक्टरिस्टिक्स असते. म्हणजे काय तर स्पेसिफिक रेजिस्टन्सची व्हॅल्यू ही प्रत्येक मटेरियलनुसार बदलत जाते. पहा, म्हणजे तुम्ही कॉपर, ॲल्युमिनियम, आयर्न, मॅग्नेशियम वगैरे असे कोणतेही मटेरियल्स घेत जा, त्यांच्याबरोबर त्यांच्या स्पेसिफिक रेजिस्टन्सची व्हॅल्यू आहे ती बदलत जाते. पण त्या पर्टिक्युलर मटेरियलसाठी ती कॉन्स्टंट असेल, पण प्रत्येक मटेरियलसाठी रोची जी व्हॅल्यू आहे ती वेगवेगळी असते. ओके, सो दॅट्स वाय इट इज कॉल्ड एज अ कॅरेक्टरिस्टिक ऑफ अ मटेरियल. Okay, this is a specific resistance. Now SI unit of resistivity or a specific resistance, rho is equal to RA upon L is the formula that we know. Now SI unit of rho, how can we calculate it? The SI unit of resistance is a ohm. SI unit of area is a meter square, and SI unit of length is a meter. Okay, so after simplifying it, we come to know that SI unit of rho is equal to ohm meter, or simply we can say SI unit of rho means specific resistance is ohm meter. Ohm meter is SI unit of a resistivity. So dear students, these are the things which you should keep in mind for your knowledge and also the examination point of view. Okay, definition of resistivity or specific resistance. We know rho is equal to RA upon L is a formula for a specific resistance. If L is equal to 1 meter and A is equal to 1 meter square, जर आपण A is equal to 1 meter square म्हटलो and L is equal to 1 meter म्हटलं, त्यानंतर मग इक्वेशन कसं बनेल? हाऊ विल दिस इक्वेशन बिकम? हे इक्वेशन कशा पद्धतीने बनेल? इफ द व्हॅल्यू ऑफ ए इज 1 मीटर स्क्वेअर अँड व्हॅल्यू ऑफ एल इज 1 मीटर, देन दिस इक्वेशन विल टर्न इन टू rho is equal to R. Correct? So with the help of this information, let us define what is resistivity. The resistivity of a material is defined as the resistance offered by a material of a conductor having unit length and unit cross-sectional area. The resistivity of a material is defined as the resistance offered by the material of a conductor having unit length and a unit cross section area. See here, from this information also, the specific resistance or resistivity of a material is actually the resistance of a conductor having unit length and unit cross sectional area. Now conductivity. Conductivity is the reciprocal of resistivity. पहा, कंडक्टिव्हिटीचं जे साइन आहे ते आहे सिग्मा. सिग्मा इज ॲक्च्युली इनवर्सली प्रोपोर्शनल टू 1/ρ. Okay, so SI unit of a sigma is per ohm per meter. All right, so these are the things about specific resistance. Thank you very much.